So in case you have any doubt about it, you ask me. Right, I'll go to first question. Metal B has twice the specific resistance of metal A. Metal B has twice the specific resistance of metal A. So rho of B is equal to twice rho of A. Specific resistance, you all know that, right? Specific resistance or resistivity is one and the same. So metal B has twice the specific resistance of metal A. A circular wire made of B has the twice circular wire made of B has twice the diameter of A. So diameter of B is equal to twice the diameter of A. Twice the diameter of wire made of A. Then for the two wires to have the same resistance, they should have the same resistance. The ratio of lengths LA by LB. So we know resistance is given by rho L by A. Correct? Resistance is given by rho L by A. So here rho stands for resistivity, L stands for length, and A stands for area of cross section. So now question here is, the two wires have the same resistance. What is the ratio of lengths? They have the same resistances. RA is equal to RB. RA is equal to RB. Resistance of A is equal to resistance of B. What is the ratio of lengths? What are the ratio of lengths? Now RA, resistance of A. So it's given by rho A, LA by A. We can write this as, okay, rho L by A, idana pi r square anta bariboda, area of cross section. Right now, area of cross section of a wire is nothing but pi r squared. So if I take this is the wire, right? So this is the length of the wire and this is area of cross section. So area of cross section is pi r squared, correct? Pi r squared, or this can also be written as in terms of diameter pi d by 2 whole square. Bariboda? Huh? Oh, sorry. Rho L by E. Rho L pi into d by 2 whole square. Correct? Right? Okay. Iga idana adar prakara tagondaga I can write as pi d by 2 whole square. This is A and this is rho B LB by pi dB by 2 whole square. Correct? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ pi cancel ಆಗುತ್ತೆ, right? So and as we know rho B is twice rho A, correct? ಅರ್ಥ ಆಯ್ತಾ? So therefore rho A LA and here rho B is twice rho A and LB. Now it's also given as diameter of B is twice diameter of A, correct? Correct? Diameter of B is twice diameter of A. So therefore this write as it is dA by 2 whole square. This one, so it is twice diameter by A whole square. Right? Now the ratio of lengths LA by LB. Right? So ಇಲ್ಲಿ LA by LB ಈ ಕಡೆ ತಗೊಳ್ಳಿ, rho A cancel ಆಗುತ್ತೆ ಅಲ್ವಾ, right? So LA by LB, so I get 2 here, 2, right? So ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡಾಗ this will be dA squared by 4, correct? dA squared by 4 and here this will be 4 dA squared by 4. ಈ 4 cancel ಆಗುತ್ತೆ, correct? Correct? Any doubt? ಅರ್ಥ ಆಯ್ತಾ? Right. Now this 4 ಯಾಕೆಂದ್ರೆ ಇದು ಡಿನಾಮಿನೇಟರ್ ಇರುತ್ತಲ್ವಾ, ಸ್ಕ್ವೇರ್ ಮಾಡಿದಾಗ 4 ಬರುತ್ತೆ, ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಸ್ಕ್ವೇರ್ ಮಾಡಿದಾಗ 4 ಬರುತ್ತೆ. So we get this. Now this is 2. So LA by LB is equal to 1:2. Quickly write down. The faster you write, can do faster numericals. The more numericals we can do. ಅದಕ್ಕೆ try to cover more numericals. a wire of resistance R is stretched to twice of its original length. Its new resistance. So it's a shortcut. If length increases by n times, resistance increases by n squared times. If length increases by n times, resistance increases by n squared times. ಅಂದ್ರೆ increase ಅಂದ್ರೆ ಇದರ wire ನ stretch ಮಾಡ್ತಾರೆ. Wire ಹಿಂಗಿತ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. This is a wire. Okay. Now increases ಅಂದ್ರೆ ಇದನ್ನ ಇನ್ನೊಂದು length add ಮಾಡೋದಿಲ್ಲ. So what we do is we stretch it. We stretch it such a way that this is L, this is 2L. Area of cross section decreases na. Area of cross section decreases by 2. A by 2 agata. Okay, we can prove that. Ardada. So let's not go into that. So just remember this. So if length increases by twice, right? So area of cross section becomes off. Ardada. Area of cross section becomes off. Are you clear? Huh? So, okay, area of cross section becomes off, and here the resistance increases by n squared times times R. Andre iga resistance enagute 2 times andre 2 squared R. So which is 4 times R. So if length increases by 3 times, 9 times, 4, 16 times. It's a shortcut. If length increases by n times, resistance increases by n squared times. So volume has remained same. There is no increase in volume. Ekandre radius ili kadame ide, radius has increased, length has decreased. Net volume is same. ಅರ್ಥ ಹೇಳಿದ್ದು. Here it is ಇಲ್ಲಿ ಏನಾಗಿದೆ, wire is stretched, the volume remains same. Here wire is compressed. ಅರ್ಥ ಹೇಳಿದ್ದು. So longer wire become shorter wire, but area of cross section has increased. But resistance changes. We all know that depending on the variation in length and area of cross section. We know length increases, resistance increases, length decreases, resistance decreases. So ಇದನ್ನ ಈ ತರ ಮಾಡಿದಾಗ, so length becomes, new length becomes L by 4. R 2R adaga hege andre like this, AL, right? A1 L1, A2 L2, correct? So A1 is pi R1 squared, this is L1, and A2 is pi R2 squared, L2, correct? So this is pi R squared, first one is pi R squared, L1, correct? This is pi 2R square L2. Artha ida? Radius has become twice na. So pi gets cancelled. R square L1, right? It is 4R square L2. So therefore L2 has become L1 by 4. Artha ida? Huh? Are you clear? So artha agila? Understood? Who is saying no? ಇನ್ನೊಂದ್ಸಲಿ. ಓಕೆ, ಈಗ ಏನಂದ್ರೆ ವೈರ್ನ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದಾಗ ಅಥವಾ ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ, ಅರ್ಥದ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದಾಗ ಲೆಂತ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಲೆಂತ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದರ ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಇರುತ್ತೆ. ವಾಲ್ಯೂಮ್ ರಿಮೇನ್ ಸೇಮ್, ವಾಲ್ಯೂಮ್ ವಿಲ್ ನಾಟ್ ಚೇಂಜ್. ದಿಸ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ. ಇಟ್ಸ್ ಲೈಕ್ ಸಿಲಿಂಡರ್ ನ, ವಿ ನೋ ವಾಲ್ಯೂಮ್ ಆಫ್ ಎ ಸಿಲಿಂಡರ್ A into L, A1 into L1, A2 into L2, correct? Volume of a cylinder A1 into L1, A2 into L2, correct? So first A1 L1, A1 is pi R1 square, area of cross section, pi R1 squared into L1. Next this is pi R2 square into L2. So pi R1 is R, R1 is R na, so pi R square L1, correct? And this one is pi R2 ಏನಾಗುತ್ತೆ 2R ಆಯ್ತಲ್ವಾ, ಕರೆಕ್ಟ್ ನಾ? 2R whole square into L2. So pi cancel ಆಯಿತು, ಇಲ್ಲಿ ಏನಾಯಿತು R square, ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿದಾಗ 4R square ಆಯಿತು. 2R square is 4R square na. So R square gets cancelled, we are left with 4. The new length has become L1 by 4. So you just have to remember, if radius increases by twice, length decreases by 4 times. length decreases by 4 times. Length increases by twice, area of cross section decreases by twice, right? Radius of cross section decreases by 4 times. Are you clear? So these are the relations you have to remember. Idana ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿದ್ದೀರಾ ಅಂದ್ರೆ these things you need not do in the examination. You will save a lot of time on this, right? Length increases, area of cross section decreases. How much you should know? If radius increases by twice, length decreases by 4 times. So that is the thing here. So length has decreased by 4 times, right? Now length has decreased by 4 times. Now length has increased andaga, length is increased by n times, radius increases by n squared times. Correct? If length decreases by ಎಷ್ಟಾಯ್ತು 1/4 time ಅಲ್ವಾ 1/n time na 1/n times, yes or no? N time, it's 4 here, n ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, 2 times 4 times whatever. If length decreases by n times, then the resistance decreases by n squared times. So ಎಷ್ಟಾಗುತ್ತೆ 1/16. Are you clear? Understood? So idu other way around. If length increases, resistance increases. If length decreases, resistance decreases. How much time this is? Length increases by n times, resistance increases by n squared times. Length decreases by n times, decreases by n squared times. 1/n squared times. ಅಷ್ಟೇ. So ಎಷ್ಟಾಗುತ್ತೆ 1/16 times ಆಯ್ತು. You would have come across this in errors, percentage increase, alva? So length increased by twice. So we know resistance is proportional to L squared. E formula, right? So then delta R by R percentage is equal to twice delta L by L. Gottidea idu? Percentage errors first piece il bandirutte. Absolute error, relative error, percentage error. Adu alla. That is errors due to what type of errors bere, calculation of error bere. Types of error bandu like instrumental error and weather related error, and error due to human beings, right? So all these things are there. There is types of errors, but calculations of errors anta baruttala. How to calculate errors? You have something called absolute error, mean absolute error, relative error and percentage error. Andre ಈಗ ಈ ತರ ಇದ್ದಾಗ ಯಾವುದೇ ಒಂದು ಈಕ್ವೇಷನ್ r is proportional to L square ಅಂತ ಬರ್ತಿಟ್ಕೊಳ್ಳಿ, ಅರ್ಥಾಯ್ತಾ? ಸೊ ಪ್ರಪೋರ್ಷನಲ್ ಟ್ವೈಸ್ r is proportional to L squared ಅಲ್ವಾ, resistance has become double ಇಲ್ಲಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, r is proportional to L squared, delta r by r percentage is equal to ಇದನ್ನ ಏನು ಮಾಡ್ಕೋಬೇಕು, ಟ್ವೈಸ್ ಅಂತ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ನಾವು therefore 2 into delta L by L percentage ಕೊಟ್ಟಿದ್ದಾರೆ, that is 0.1%. Therefore it is 0.2%. Okay, so I think adu errors ಬಗ್ಗೆ discuss ಮಾಡಿದಾಗ if I take up I'll discuss that. ಇಲ್ಲ ಅಂದ್ರೆ whoever teacher comes about, again adu ಒಂದು ಇದೆ ಚಾಪ್ಟರ್ ಇದೆ, units and measurements, again we discuss it, crash course ಅಲ್ಲಿ ಇದೆ. So ಅದು discuss ಮಾಡಿದಾಗ we'll discuss that. Okay, so point 2, specific resistance of a wire is rho, its volume is 3 meter cube and its resistance is 2 ohm, then its length is, so R is equal to rho L by A, rho L by A. But ಏನಂದ್ರೆ ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಕೊಟ್ಟಿಲ್ಲ, they have given volume. So therefore R is equal to rho ಇಲ್ಲಿ divided multiply by L ಮಾಡ್ಬೋದಾ, right? A into L is volume, correct? So therefore it is R is equal to rho L squared by B, correct? Now they have asked for what? Length. Then its length will be equal to, so L square is equal to R into V by rho. Bariboda? So length is equal to R into V by rho. So resistance ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ, specific resistance ಕೊಟ್ಟಿದ್ದಾರೆ, it is given as rho, ಕೊಟ್ಟಿದ್ದಾರೆ, resistance is 3, right? And volume is 3 meters cube, right? And specific resistance is rho. Therefore L is equal to 9 ಬರುತ್ತೆ, square root of 9 is 3 rho, 3 by rho. Question number 6. Three wires of same metal, like it could be copper or whatever metal, on the ratio of, so masses are in the ratio of M1 is to M2 is to M3 is, it is 1 is to 2 is to 3, and their lengths, so L1 is to L2 is to L3, it is 3 is to 2 is to 1. The electrical resistances on the ratio of, so what are, because mass is given, but we know resistance is given by rho L by A, correct? So they are of the same material, so therefore rho is same, correct? Rho will not change now. Does rho depend on length? Does rho depends on length? No, it does not depend on length or area of cross section. It's constant. Resistance is numerically, resistivity is numerically equal to resistance of unit length, unit area of cross section. So R is, rho is constant. Therefore, R is proportional to L by A, right? But illenandre they are given in terms of mass and length. Idana barkoli L squared by volume. Bariboda? A into L. Data barita idini. No confusion na? Right. R is proportional to L squared by V. But they are given masses. So L squared by, right? Density is mass per unit volume. Density is mass per unit volume. Correct now? Density is mass per unit volume. They have given volume. So therefore volume is mass per density. Correct? Correct now? But density, it's of same material. Therefore R is proportional to L squared by M. Since it is of same material. It is same metal. So if it is the same metal, density is same na? It is same metal. So therefore density is same. Therefore R is proportional to L squared by M. So which means that, right, R1 is to R2 is to R3 is equal to L1 squared by M1, right, is to L2 squared by M2 is to L3 squared by M3. Correct now? So L1 squared 9 by 1. Correct? Next L2 squared 4 by 2. Correct. Next 1 by 3. Right? So this is 9 is to 2 is to 1 by 3. Now multiply by 3. ಏಕೆಂದ್ರೆ ಈ ಥರ ನಮಗೆ ಓಕೆ ಈ ಥರ ಬಂದಾಗ ನಾವು ಫ್ರಾಕ್ಷನ್ಸಲ್ಲಿ ಇರಬಾರ್ದು. ಸೊ ಅದನ್ನೇನು ಮಾಡ್ತೀವಿ, ಈ ಥರ ಬರ್ಕೊತೀವಿ. R1 is to R2 is to R3. So it is 27, 6 is to 1. Okay. So option number D. So 8th question. So if a wire of resistivity rho is stretched to double its length, then its new resistivity. If a wire of resistivity rho is stretched to double its length, then its new resistivity will. ಬರ್ಕೊಂತ ಇದೀರಾ ಇನ್ನು? New resistivity. Huh? Why? Remains same na? Because resistivity does not depend on length and area of cross section. It's a constant. Resistivity is numerically equal to resistance of unit length and unit area of cross section. Therefore, not change. Next one, 9th question. Question number 9. Dimensional formula. Dimensions of electrical resistance. Dimensions of electrical resistance. So R is equal to V by A. ಜ್ಞಾಪಕ ಇದೆಯಾ? Do you remember what is the dimensional formula? No, not this. I'm talking about dimensional formula. Okay, no problem. If you don't remember, just do this way. R is ratio of potential difference by I. Correct? So idina potential difference na we can also write it as E into D. Baribada? Because E is equal to V by D. Right? This is I. Huh? Okay, ಅರ್ಥ ಆಯ್ತಾ? Right. So this will be E andre it is Newton per coulomb na. Okay, into D. Okay, into distance D by I. Right? So it is Newton is MLT minus 2 na. Dimension formula MLT minus 2, and down we have Coulomb. Coulomb ge bandbitu, right? So I is Q by T. Are you clear? I is Q by T. Q by T. Therefore Q is equal to I into T agata. Ekandre we don't have fundamental units for charge. We have for ampere. I mean current is there. So therefore Coulomb ge we can write as ampere into time. Correct? It's in denominator. And now this is dl, and this what about current? Current is ampere. So therefore it is ml squared T minus 3 ampere minus 2. Huh? T minus 3. Option number B. Correct na? Option number B. Ampere is flowing through a conductor. 4.8 ampere is flowing through the conductor. The number of electrons per second will be. So we know definition of current. 10th question. Definition of current is I is equal to Q by T. Correct? Definition of current is I is equal to Q by T. So now this is charge per unit time. So current is 4.8 ampere per second. T is 1 second. It is Q. So therefore Q is equal to 4.8 coulomb. Artha aita? Current is given as 4.8, right? So we'll have to find out Q. T na 1 anta tagolli, 1 Q. So therefore Q is equal to 4.8 coulomb. So what do we have to calculate? Number of electrons. So we know this. Q is equal to plus or minus n E. So therefore Q is 4.8, right? N into what is charge? 10 to the power minus 19, right? So therefore n is equal to 4.8 divided by 1.6 into 10 to the power plus minus 19. So this is 3 into 10 to the power plus 19. Option number A. So the number of electrons per second. Sometimes they give it as charged particles anta keltare, right? Charge negative anta bandre avaga enagutte, it will be negative barutte illi. That means electrons. The charge is negative, electrons. Charge is positive adre enagutte, it will be protons. So bivalent, you know, bivalent means twice. Bivalent positive ions. Positive ions drift to the right. They are drifting right towards right per second, and while 3.6 into 10 to the power of 18 monovalent negative ions drift to the left per second. Arthata? Now next is, then the current is left per second, then the current is, what is the current flowing through this? So we know definition of current is, it is, what is the direction of current? From positive to negative end. Alva? Ishtu, this is bivalent positive ions are moving towards right. This represents current. Andre equal number of negative bivalent ions are moving this direction. Arthata? Net ಏನಾಗ್ತಿದೆ? 3.2 into 10 to the power of 18 bivalent positive ions are moving this side. So we have 3.2 into 10 to the power of 18 bivalent negative ions are moving towards left plus this. Arthata? Are you clear? I repeat again. So again the definition of current is how much of the positive ions are living from positive end to negative end. Electric current andre, so positive end inda negative end ge ಎಷ್ಟು particles ಅಥವಾ whatever ions, right, protons, whatever move from positive end to negative end, that constitutes current. That is the definition of current. Andre illi 3.2 into 10 to the power of 18 bivalent positive ions are moving towards right. Correct? Which means that 3.2 into 10 to the power of 18 bivalent negative ions are moving this direction. Howdu? I repeat again. Definition of current is positive ion to negative ions. Ardha? So, Samanya, now current and Dakshana, how many electrons are moving from negative to positive? If electrons are moving, so many n number of electrons move from negative to positive. So, same number of positive ions move from positive to negative. The current direction is positive and negative. Whereas electron direction is lower potential to higher potential. ಇಲ್ಲಿ ಎರಡು ತರ ಕನ್ಫ್ಯೂಸ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ ನಿಮಗೆ. ಅವರು ಏನು ಮಾಡಿದ್ದಾರೆ ಎರಡು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ 3.2 into 10 to the power of 18 bivalent positive ions are moving from where to where? Right to left. Positive to negative. Correct na? If they are positive, they move from positive to negative, right? Yes or no? They are moving from positive to negative, which means that an equal number of negative ions are moving from negative to positive. These are bivalent. Correct? So therefore, an equal number of negative ions are moving from negative to positive. Plus, we have 3.6 into 10 to the power of 18 monovalent negative ions are moving. Okay. So net enagutte. So the current is basically here. If I talk about current, so basically it is number of electrons moving per second. The number of electrons andre illi bivalent anta kodidare. So therefore, charge of that is twice. So therefore, current is moving 3.2 into 10 to the power of 18. Correct? This is numbered. Alva? So Q is equal to N into E, alva? Correct? So I is equal to Q by T. T is always 1 second. Correct? T is 1 second. Ivaga now Q calculate ಮಾಡ್ತಾ ಇದೀವಿ. If you are calculating Q, that is equal to I. ಅರ್ಥ ಆಯ್ತಾ? Because I is equal to Q by T. T is 1 second. Therefore, if you are calculating Q, so you are estimating per second, and that is nothing but I. Understood? Understood? Okay, this is quite common question. No? Okay, negative ions, positive ions, and resistivity, resistance. So most likely to be asked in the examination, CET. Now this is I antandre. So first we'll take positive ions are moving from right to left. So 3.2 into 10 to the power of 18 into what is the charge of them? Bivalent. Bivalent is 2E. Correct? Bivalent. It is 2E. Correct? Correct. Plus. Okay. Idadmele, what we have here? 3.6 into 10 to the power of 18 monovalent negative ions. Ilenaktide plus 2E into this number and minus C into this number. I'm moving this direction. So ನಾವೇನ್ ಮಾಡಬೇಕು ಇದನ್ನ ತಗೊಂಡು ಇದರದ್ದು ಪ್ಲಸ್ ತಗೋಬೇಕು. ಯಾಕಂದ್ರೆ ಕರೆಂಟ್ ಅಂದ್ರೆ if the negative ions are moving, same number of positive ions move opposite direction. This plus this ತಗೋಬೇಕು. ಓಕೆ, ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಕ್ಕೆ ಹೋಗಬಾರ್ದು. ಇದು ಪಾಸಿಟಿವ್ ಬಂದಿದೆ, ಇದು ನೆಗೆಟಿವ್ ಬಂದಿದೆ, ನೆಟ್ ಅಂತ ತಗೋಬಾರ್ದು. ಅರ್ಥ ಹೇಳಿದ್ದು? This positive ions are moving. Because of this negative ions are moving, an equal number of positive ions move. Okay. So therefore, current will be equal to 3.2 into 10 to the power of 18 into 2E plus 3.6 into 10 to the power of 18 into E. It's monovalent. Monovalent. Okay. Now this will be equal to 3.2 into 10 to the power of 18 into 2 into charge is how much? 1.6 into 10 to the power minus 19 plus 3.6 into 10 to the power of 18 into charge 1.6 into minus. Okay. So this will be okay. So 3.2 into 3.2, correct now? Right? Into minus 1, correct? Plus 18 minus 19, correct now? Plus 18 minus 19 is minus 1 plus this one. Huh? No, plus 18 minus 19 is minus 1 na? Oh, sorry. Okay, now have you multiplied this? 3.6 into 1.6. How much is this? Huh? 3.6 into 1.6. 5 5 into 10 to the power of minus 1. So 3.2 into 3.2 is how much? 6 point? Plus 10.24 na, we can write as minus 1 irodinda, we can write it as 1.024 na, plus this one 0.576, therefore it is 1.5. Okay, roughly 1.6 to the left. ಯಾಕೆಂದ್ರೆ ಅಲ್ಲಿ ಕೇಳಿರೋದು current is to the left correct? Current is from positive to negative to the right 1.6 ampere to the right, because negative ions ಇಲ್ಲಿ negative ions direction ಕೊಟ್ಟಿದ್ದಾರೆ left to right ಅಲ್ವಾ, so therefore positive ions is from right to left, not right to left, left to right. This is left na. ಅರ್ಥ ಆಯ್ತಾ? ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಹೋಗ್ತಾ ಇರುತ್ತೋ ಆ ಡೈರೆಕ್ಷನ್ ತಗೊಂಬಿಡಿ. ಇಫ್ ಅಟ್ ಆಲ್ ಎನಿ ಕನ್ಫ್ಯೂಷನ್ ಇಸ್ ದೇರ್, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂತ ಇದೆಯಲ್ಲ ಆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್. ಇನ್ ಕೇಸ್ ಯು ಹ್ಯಾವ್ ಲೆಫ್ಟ್ ರೈಟ್ ಕನ್ಫ್ಯೂಷನ್, ಅರ್ಥ ಆಯ್ತಾ? ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತಾ ಇದೆ? ರೈಟ್, ಸೊ ಟೇಕ್ ಇಟ್ ದಟ್ ವೇ.